In this video, we'll give you a short introduction to this chapter on data manipulation in R. The main purpose of this chapter is to get you comfortable in using R to manipulate your files, particularly the sort of files you might encounter as an actuary. These are things like model point files or other data files from valuation models. So the first part of this chapter deals with working in files. So if you work through this, you'll see different commands that you can use. A lot of them are to help you to quickly access data files in different folders. So we'll cover that bit first. And then the second part deals really with data manipulation. So we will introduce how to use some packages in R that can help you to apply data manipulation. So to get all the material for this course, you'll see a zip file for this chapter, and you should just download that zip file and extract it into your own folder. And then once you've done that, just remember to create a new project and point to that directory. So it's always good when you start a piece of work to understand what your working directories is. In this case, if I run this command, it'll give me a directory which is the project directory. There are commands where you can use to change the working directory, but I don't recommend doing that with standard code. You always want to make sure that you're using relative file paths. So for you use a folder that is relative to your working directory, and I'll show you what that means. So one of the things you might want to do is to be able to list some folders in a directory. So running this command, if you look at the bottom here, it's pulled in all the folders in that path. Another way to look at it is if you look on the right here, in R, you can see a window which shows all your files in your particular directory. It's also useful if you were to click the settings button on the right, you'll see that you can change working directory or go to the working directory interactively. So you can see this command produced the files in the directory. There's commands you can use to create directories as well. So this function creates a folder called new folder, and if I run it, you'll see there's a folder called new folder, and there's a command where you can check if a folder exists. And that could be useful, for example, if you want to run a process, but first you want to make sure that the folders you need have been set up. There's commands for removing directories. Again, there's this option which allows you to state whether you want to delete all the underlying folder and its contents. Renaming directories is something you might want to do, or moving directories from one area to another. So for example, this code takes this file and renames it to that, or it takes this file and it moves it to another folder. In this case, it moves it to a folder called data. So one of the things that we talked about earlier is how to read the files. So for example, running this line of code, it basically reads in a file from our home directory, and you can see on the right, that's the file that's written in. But we might also want to write that file out. So R allows you to write to a specific folder. So for example, you can load this, do some analysis, change some data, transform it, and then write it. There's also information on how to work with files. So a useful command is to be able to list all the files that are in a specific folder. This is quite good. You can also list files that have a specific pattern. Again, this enables you to quickly identify and get a list of all the right files you might need. Uh, One other thing you can want to do is just to delete files. So there's commands file.remove, and you can try these out to see how it works. Uh, Sometimes you want to get the full path of a file. So for example, you can find the file name in a certain directory, but you might want to get the file name and you use it for to run another process. This is especially true where the file names change from month to month, for example. Uh, you can copy files, and you can actually, in this example, we read in a file. Um, we, we we look at the data, we call it something else, and then we write it to another location. Uh, so that's so please review that. These are quite useful. Are sort of functions that allow you to effectively work with your data sets. The next thing I want to talk about is data manipulation with R. This is really the key, I guess, a key function of R is it allows you to manipulate data and access it quickly. So just a reminder, to do data manipulation in R, we'll be using a package called dplyr. It's part of the tidyverse package. So effectively, tidyverse is a collection of R packages that are all good at data manipulation. So we'll go some of the key functions, and you can see the examples in the document. The sort of things we want to do is to be able to filter certain records. So if you've got a large data file, you might want to only look at records that meet particular criteria for a particular product, particular fund. You might want to select only specific columns. You might want to order things, but a lot of the time you want to transform those columns, so maybe create new columns, maybe summarize it and group it. Um, and really, once you can do data manipulation, it will help you become more efficient in automating day-to-day tasks in R. So the first thing we will look at is how to, I guess, load data into R and just select specific columns. Um, so first of all, we're going to load this package called tidyverse. Um, and as we said, this package includes a number of sub packages, and included in that is the package called dplyr, which we'll be using. So we can see we've created this data file called mpf. You can see there. Uh, and if I just click it so that we can have a look at what's in there, you can see this file has got quite a few columns. This is a typical data file you can expect in terms of model data, model point file data. Uh, Now what we can do is, instead of clicking it like just I showed you, you can use this function called glimpse, and that allows you to see, and you can look at the output at the bottom here. You can see all the column names and the data types. So you can see there's some characters in there. Uh, Now, what we can then do is, a lot of the time we never want to work with all the columns. So one way you can do it is you can just create a new table, and then use this command to sort of select different columns. So if you run this, you'll see what happens is that you end up with a file that has fewer columns, only the ones we want. And then you could then use it to do your analysis. A cleaner way is actually to use the select function. So this does exactly the same as this code here, but as you can see, it's a lot cleaner. You don't need to put codes. Um, you can also select a group of columns. So for example, this column will just look at columns that start at a particular variable and end another variable. You can select all columns apart from a few columns using that code as well. And sometimes what you can do is this is quite useful because sometimes if you want to remove quite a few columns, you can sort of remove certain bits and then sort of add in the bits you want later. So for example, this code is removing all the columns from the start to this particular variable. It's also removing all the columns here, but then it's adding back in one of the columns. Renaming is also quite a useful thing we want to do. So for example, within the select statement, you can see if you have this comment here, you can rename a column as you select it. Again, which is quite useful to do. So you can see in this case you've renamed this variable to be premium instead of this arbitrary name. And there's also a rename function you can use. The other thing you can do here is to, I guess, transform data by adding columns. Or so in this example, we're going to load a data file, which is data file. You can see the columns here. It's a data set which has information about lapses. So it's a type of file you might use if you're doing lapse analysis. So it tells you useful information. For example, if I just open it, you can see it's got columns telling you like your exposure, your lapses, how many policies lapses, the age, so and different sort of variables there. So what you might want to do is, for example, you might want to add an extra column which just calculates the lapse rate just by looking at the lapses over the exposure. So this code, you can see you create a new variable and you tell that variable that it's going to be a calculation. And when you do that, you can see it creates this extra column at the end, and that extra column has your lapse rate shown over there. One of the benefits of transforming with this function here, this mutate function, is you can do a lot of transformations in one step. So in this example, you're taking your data, you're creating new columns, and or you're incorporating calculations as well. So you can see down here you've done multiple transformation using one line of code. One thing that's quite useful is that whenever you have categories, a lot of the time, by default, that data is loaded in as text. So we need to tell R that we are dealing with categories. For example, for things like gender or any other variables that you know are categories, just use this command which sets them as a factor or a category. And if you do that, you'll actually see that data has been converted. So down here you can see it's changed gender into a factor where previously it was a character. Sometimes you might want to just check without having to look at all the variables, you can just check the type of its variable. So if you run this class command, it'll tell you down here what class, what type it is. I find this useful. Sometimes you might convert all characters into factors. So typically in a file that you load in, let's say it's a file showing policy data, you'll know that if there's any sort of text data in there, it's usually some sort of category like product or gender or some sort of flags as well. So sometimes you might just want to change everything that is a character into a factor. So that's why you have this mutate if function. It sort of takes in your data and then does a true or false statement across all your columns, and then applies this transformation. So again, that's quite useful command to do. what we might want to do is, for example, if you have a categorical variable, in this case, we've got this variable called face amount band. So if we just run this, you'll see you've got these four categories. But sometimes you might want to group them differently, um, and this is where this recode function comes in. So sometimes your data might have multiple categories, but you might want to summarize them down into more useful category, and sometimes it could just be in this example, you just want to change it to either less than 250,000 or greater than 250,000. So that's what this code does. Uh, so again, quite useful because you end up then splitting your data into more useful categories. Filtering is quite a big task in the sense that a lot of the analysis you want to look at records that meet specific criteria. And so what we'll do is, again, if you load that data in, so that's our full data set loaded in using this command. And then if you use the filter function here, what we're going to do is create a new data set, and we're going to filter for records that have a specific duration, for example. And you can see on the right there that we end up with this data set, which is much smaller, but all the records in that have that specific duration. You can filter based on multiple conditions, so you might want to filter on duration and gender and age group, and you can apply all the usual equals or less than criteria. You can filter for specific ranges. Again, you might want to filter for ages between certain values. And then sometimes you might want to do the sort of either or type filters. Next useful sort of technique in R is how you do what I'll call pipe operations. So a lot of the times you want to apply a sequence of transformations. So you've got a data file and you want to do a transformation, and then using that transformation you want to then do another transformation. So in this example, we want to do a couple of things. We want to read in the data. We want to do filtering for specific records, and then we want to take that data set and then apply some changes. So that you can do that, but as you can see, you would have to follow lots of different steps. A cleaner way is to use this pipe operator. So effectively, it avoids, I guess, repetition. So for example, you want to create this data file, and effectively you're going to read your data and then pass this, what this um, symbol represents is effectively it just passes the results on the stuff on the left to the next line. And it basically means you can just uh, you don't have to create these intermediate, I guess, tables in your analysis. You can just run your analysis all at the same time. So you'll see that quite a lot in our code now. I guess one of the most powerful things you can do in R is grouping and summarizing. So in this example, we sort of put everything together. We read our data set, and then what we're going to do is we're going to transform some variables. We're going to do some filtering, and we're going to convert some variables from characters to effects, all in one step. And one thing you'll notice with this code is it's quite clean and quite easy to read. Effectively, you just look out for this symbol and you basically read it as take the output on the left, pass it into the right. Now, what we might want to do is to sort of do summarizing. So there's two functions that we need to use. There's a function that summarizes data in some way, and then there's a function that groups data in a certain way, and the idea is to combine those functions to produce a useful output. So to give you an example, you might want to answer the question, how do the lapse rates differ by duration? So if you remember, we've got a data file, and we've got duration, and we've got information on lapses and exposure. So we can calculate lapse rates by duration. So what we can do is first uh, group it by duration. So if you look at this code, what it's saying is just take your data, and then first you're going to group by duration. Now, what that does, it just takes your data and it basically categorizes your data into different duration buckets or groups. And then it takes that group data and you're now going to summarize it. So now R knows that whatever it will do after this line, it will do it for each group separately. So what it will do is it will create it'll sum the total number of lapses for all those records that have that duration. It'll sum the exposures, produce a count, and then finally it will calculate a lapse rate. So you can see at the bottom here, you've basically ended up with a table where you've got your lapse rates summarized by duration, and you can see we're using all the functions we looked at above, particularly this mutate function, which allows you to create this new columns. You can also ask, how does it vary by duration and gender? Again, you just add an extra grouping variable. So now you're grouping it into duration and gender, and then you're summarizing it. And if you run that, you'll see now we've got slightly longer table, and then you've got a lapse rate for each gender and age combination. Sometimes you might want to allow for missing data. So because in some of these calculations, there might be rows that have missing data, and the way to deal with it is just to make sure you include this na.rm equals 2 effectively allows the calculation to carry on ignoring the missing values. Sometimes when you summarize things, you might want to include a custom function. So we covered functions in an earlier topic, but effectively you might want to pass a function to a column. So in this case, this is a simple function. All it does, it takes the value in a specific column, subtracts it from the mean, divides by the standard deviation, so standardizes it. And now you can see down here we can do our summary. We group the data by duration and gender, and then we'll summarize it, and we create a new variable which effectively is based on calculating the z-score for that specific column. So you can see that this table now, so if I just open it, you'll see you now have this column on the right, which is just a z-score. Now, next thing we want to talk about is joining data sets. This is something that you might want to do because sometimes you get data from different sources and you want to join them. And the classic example is you've got some model output, but that model output doesn't have all the fields. So you might want to sort of join it to some other raw model point data to get more details about the policy. And there's a list there you can go through to look at the different types of joins. But essentially, I'm going to run through the main functions. So what I'll do is I'm going to load two files. The first one is a list of policy data, so just policy features, and then the second one is output from another process evaluation model. And if you look at both of them, you'll be able to see. So if I open this one, for example, you can see it's got policy number and some valuation fields. Uh, it's got a bell, present value of expenses, typical fields you might find in a validation, in a valuation. And then you've got this file, which is a model point file. So again, it's got more policy type features. And what we want to do is to see the different ways we can join them. So one thing we can do is we can do an inner join. All this does is that it looks at all your records, and based on a particular key. In this case, we're using policy number. It joins those data sets, and it does that by returning the fields that are in both data sets. So, for example, if I run this, you'll see that you end up with a data file. It's got slightly less records than the original file we joined, but that's effectively that's because this file here had fewer records. You can also do a left join. Now what that does is it keeps all the records in the dataset on the left. Then it just adds in what it can join. It adds those extra columns, but then effectively you will end up with some NA values in some of the rows, because not all of the rows are matched up. Again, there might be cases where you might want to do that. This is the one I tend to use the most because I typically never want to lose the data in the data set I'm looking at. You can also use a right join. Again, it does the opposite of that. Or you can do a full join. It basically ends up with a larger data set which tries to include everything from like the union of all the columns. And there's other functions that you can try, like semi-join and anti-join. And these are all trying to tell you how you can link data in different files. So the last thing to go through is this assignment. So there's an assignment just to train and to practice everything in this chapter is we'll effectively read in a file, an Excel file, um, update some of the variables, create a new tab, and to place some values. So there's a list of tasks, and effectively this, if you can do all the steps in here, that'll give you good practice on how to read and manipulate data in R. Hope you enjoyed this chapter, and yes, we will see you in the next video.